Okay, so it's I think we can start. There is a question in the chat about the packages that we need to install during yesterday and today. We will work with the tidyverse. Today we will see an example for visualization using the package xbin, but if you want, you can install it, but it's not it will be a tiny example, so it's up to you. And tomorrow there is a part that using R and SQL, and we will use another library called RSQLite. So again, also the sample that we will see tomorrow will be quite short, so up to you. If you want to install it or if not, that's fine. Today we will continue. We will see first how to work with the date, and then we will continue manipulating data, doing some queries. The queries that we will do today are, if you have seen before databases, the concepts are pretty similar. And tomorrow we will see similar way using SQL rather than R. But we will see that you can use both and choose the one that you feel more familiar with. Actually, you know that, for instance, there are some databases that are available that maybe you need to know SQL in order to manipulating data, but it is also possible to use R and manipulate the data using R. So, but it's good to know both ways in order that one of them is not available. You can find the case that only SQL is available, or well, the other way around. Yeah, could be that also that the only access that you have is using R. So okay, so let's start using dates. You may see when you open RStudio that if you see the top right, that the environment is empty. That means that we don't have anything in memory. So in order to keep working with we will need to load the data set and start working with that. Okay, I will write a comment here, Wednesday. Well, rather than a comment, the date, 26. So we would need to load the tidyverse, load the libraries. If I remember right, it's a library tidyverse. Execute something from the text. You need to press Control Enter, and you will see here on the bottom that this is loaded. There is a comment in the chat. Is this a new script from yesterday? No, actually, I'm using the same as yesterday, but let's say I keep writing things. You may have active when you create a project. You can choose if the environment is saved on disk or not. If you have things loaded from yesterday, it's fine. So let's see that you don't need to load the library and load the database. And now we will need to load yesterday we were using the variable surveys. And remember that the function that we were using is read_CSV, and we were specifying the the root of that is a data row portal data join.csv. So if I execute that with Control Enter, you see that in the output that this is like this is loaded. Also, I will need to load the library Lubridate. This library, I will write that in the chat. This library belongs to the tidyverse, but it's not loaded by default. So we will need to use the library Lubridate. That's what we have there in the help. That this is well, the kind of slogan, dates and times made easy with the Lubridate. Oops. So Control Enter. And again, I got this warning that the warning said that these 4 functions, when we execute them, will execute these functions will use these functions are defined in Lubridate, so this when we execute date, we'll use the function defined in Lubridate rather than the function defined in the package base. This is the warning that we get. So now we can work with the objects with the dates objects. So we have we can set my_date. Remember, assignation symbol is with the alt minus, and the function is ymd. I see that some people didn't receive the warning. It's fine. It's not. Could be maybe the version of that I'm using a different version of R, or could be, but it's not. It's fine. It's not a big. It's just a warning. So, and we will use today's date. That is with the this function. We will need to use the standard that we saw on Monday, the ISO standard. That is the standard. We'll write this in the comment. It's year using 4 digits, then the month, and then the day using 2 digits and 2 digits. So we use 2023. Month is April, so it's 04, and day is 26. So if I execute that, I can see the str my date. I think I need to execute that. You see that the type that we have is the date, and the format is this year, month, and day. Also, there is a way in case that, because you know, in this for this survey or for this data set, we have 3 columns. We have a year, month, and day. What we will see now is how to create a column with the dates. So to do that, we can use the first. We will learn the function color paste. In paste, this is like more it's a concatenation of. So here you can say 2023, the month 04, and the day 26. And also you can specify what we will use to separate each component. So we will use the hyphen minus symbol. If you execute that, you see that you have an output, something like that. So if you use now the function ymd and you execute that, you will get this an object of called with a date object. So following a similar, this is just for one date, but one good feature of R that is that you can work with the vectors, large vectors. So we can do the same with paste. Well, let's go step by step. First, we'll use paste. For the year, we will use surveys $year, surveys dollar, if I manage to write dollar, month, surveys dollar day. So now I have a year, month, and day, and again I will use the separator. I will use this. I will surround this with the function YND, that is year, month, day. And when I execute that with Control Enter, I get well, it's like a print max. I get all of this date in this format, and I get a warning message. I get that 129 are failed to parse. We will see later why, but yeah, it seems that most of the entries have been converted to date, except that one. And a good thing that we can do is, well, we can do str surveys. We see that we have 13 columns of numeric character, etc. But we can create a new column called date, and we will save the output of this in this new column. So to create a new column is surveys $date assignation symbol, and what I will do is I will copy and paste this line. And with that, I will create a new column of execute that. Then I get the warning that is 129 to parse, and I can do a summary of this column, surveys $rate. Well, you get some statistics, and also you get the missing values of 129. And if you do again str surveys, you will get now that you have 14 columns rather than 13. And the last one will be date. Okay, so now we will figure out what happened with these missing values. Why this is happening? So what we can do is we can create a new data frame. We will call it missing dates assignation. And what we will do is we will do a subset of the surveys. You remember yesterday we were using square brackets. So now what I will do is I will select the rows. I will select the rows that are NA, survey date, and I will select the columns to see what happened with the columns that remember to use a vector, you need to use the function C, and the columns will be year, Another feature that is that you can use the name of the columns rather than remember the number. So you execute that, and now we will print the first missing date, and we will figure out what happened. So this is an example of the dates that I have that didn't parse. Did you see something wrong with this date or what? So do you know why they didn't parse to a date? We got an error when we try to use, for instance, 31st of September 2000 or 31st of. So yeah, exactly the problem that we have here, that this is like also one of like risks that you have when you save the data in, let's in this format of a year, month, day. Unless that you don't check that, you can say, okay, 31st of September, that doesn't exist because September has 30 days, and it's the same with April. And also we can say like even like a 30th of November, sorry, 30th of February, that doesn't exist. So one way, for instance, what we learned on Monday is to check when we introduce a date, to check if the date is valid or not. So in these cases, we can either we will need to if we make a decision, we will need to document that in our metadata document. We can either say, okay, I will get the data that is closer to this. I can say 30th of September or 1st of October, or I can keep them as a missing data, and because it's only 129, I can get rid of them. We would need to make a decision based on this. Okay, so this is what I wanted to show regarding data, and what we will do now is we will start. We will learn two new libraries that are deploy and tidyr. So these libraries are already loaded as part of tidyverse, and the idea of these libraries is that we will do queries to the data. I will copy here in the what we will learn. So we will learn, we have our survey, and we will perform some operations like select, that is subset columns. Yesterday we did that using the square brackets, but now we will use a function that could be easier and more readable. We will use a filter to subset rows on conditions. We will use mutate to create new columns by using information from other columns. We will use a group by and summarize to create a summary statistics on group data, arrange to sort the results, and count to count discrete values. So let's start with the select. So select, the idea is to select columns from. So we have a surveys, and we execute it. We get all of these. We get by default all the rows, but we can use the function select the first argument will be surveys, and the second, third, etc. will be the names of the columns. So I can write a year, month, day, and if I execute that, I will delete it, otherwise it will be all the time. So performing this, I can select the columns using this function. This is similar with SQL. If not sure if you have seen any of it, you can use select year, month, day from surveys. So this is the same idea. Also, you can imagine that you don't want to have these columns, so you can use minus. You can do select surveys minus year minus month minus day. So when you execute that, you get the rest of the columns except the year, month, and day. So this is what we want to do. Well, we want to learn regarding select. The second function that we have available is a filter. So I can do. I'm interested in for instance, in the observations that are from the year 1995. So I can execute the function filter that also here says from the library that you're using. Well, here we get again like some information. So the first argument is the data set that we will use, surveys. And the second argument is the filter that we will use. So year equal, so well, we use a double equal, otherwise for comparison, otherwise it will be an assignation, 1995. So when I execute that, I get 14 columns, so all of the columns, but the table has 1,180. So get all of the entries. You see that year is 1995. And also we can combine select and filter. There are several ways. One way is to use this filter and then use you can do something like this, select the first argument will be this function, and then we can use minus year, minus month, minus day. So we can get something like that. The problem is when we this is one way. Another way is to use a variable and save the output of this in a variable and use that variable to select. But the problem is that we will use a lot of memory to do that, also for large data sets. And also the readability could be a little bit difficult because, okay, here I'm using two functions, so it's still readable. But today we will see examples that we will need to use several functions to get the data that we want. So that will make things not readable. So the concept that we will see here is the concept of a pipe. Pipe is you have your data set and you are performing some operations to the data set until you get the desired result. so to get that, to do a pipe, the way is to do surveys, and then for the pipe, you need to use the pipe could be written with the percentage symbol, greater than symbol, and percentage symbol. So this is the pipe. I will copy that in the chat. But there is a way with RStudio to write that using a key combination that is Control Shift M. I will write also in the chat that Control. So executing that combination, you can write a pipe. So you write the surveys, and now you can do, for instance, you can do the filter. Because you're using a pipe, you will not need to specify any longer the data set. So you can just write the condition, year equal 1995. Here I will need well, you can execute that, and you get this output. But if you want, also you can do a select. So we use Control Shift M, and I do select. And again, because I'm using pipes, I don't need to specify the data set. So select. I didn't want to get year, month, and date. So you see, you execute that, and you get this output. Okay, now to see if you have understood this, we will do what is called a challenge or exercise. This is this one. So the exercise is using pipes, subset the survey's data to include animals collected before 1995, and retain only the columns year, sex, and weight. Once that you finish the exercise, please say so in the chat, and I will continue. So now the structure of this part is we will do an exercise with the function that we have learned, and we will continue. So it's just to check that if we have understood the concept of the functions to manipulate the data. I will copy this in the chat as well. I see there is a question in the chat asking about this symbol. This is a pipe. So the idea of what a pipe is the output of this is the input of this function, and the output of this is the input of this. This is kind of a fancy arrow, or I don't know if that makes sense. That is because when I execute the surveys, I get an output. I get this thing. So what I'm doing is I'm using this output as an input of a filter. So if I execute a filter as is, well, they said that gives an error because I didn't specify any data set. So what I need to do is I will need to send the output of this to the input. So for that I will need to use a pipe. Here for simplicity, well, here I have used several lines, but you can also use write that in the same line. So now if I execute this line, the output of this will be the input of that. So if I execute this, I get the surveys, but with this filter applied. This also could be read as a then. So I get surveys, then I filter by year, then I select. Is that clear now, or do you have any other questions? Sorry, I was talking and I didn't realize that I muted myself. So the idea of this exercise is using pipes subset the surveys data to include the animals collected before 1995 and retain only the columns year, sex, and weight. When you finish with the exercise, please say so in the chat and we will continue. But yes, I will give you some time to do that. Okay, I see that some people have finished the exercise, so I suggest like solving this together. Okay, so the challenge using pipes set the surveys data. So surveys, pipe, include animals collected before 1995. So I will need a filter year should be less than 1995 pipe because I'm only interested in the columns year, sex, and weight. So this will be the exercise. I have 3 columns, more than 21,000 observations. So this is the way of the next thing that we will learn is we can use mutate. Mutate is when we want to create a new column and we may want to make the new column either to do some plotting that we will see that later, or for some to make some calculations, or we will find a case that we will need to do that. So to use mutate, I will show an example and then we will do another exercise. And we will use surveys, pipe, and I use mutate. A mutate here I need to specify the name of the column. For instance, I will I have the weight in grams. I will use kilograms. So I will weight underscore kg equal the column weight divided is this 1000. And also if I want, I can just print the first result using the function head. So again, I can use a pipe here and use the function head. So if I execute that, you see that well, I don't get, because I get 15 columns, but there is no space because they started with 2 more variables, date and weight. So when I print everything, I don't get the. So one thing that I can do is I can add a select, and I can say select weight kilograms, date, no, genus, for instance this, and don't forget to include the pipe. But well, the way that I have is I can select it here, and 20, I think is the, okay. So here I get that the weight is this column, and the weight in kilograms is this new column that is here. Now we will do this challenge. I will copy that in the chat. And also I will copy that here. So we will do this. We will create a new data frame from the service data that meets the following criteria. Contain only the species ID column and a new column called hindfoot centimeters, containing the hindfoot length that is in millimeters, converted to centimeters here. And in this column, there are no NAs, and all values are less than 3. Again, when you finish the exercise, please say so in the chat. I will give you 5 minutes. Okay, so I suggest let's go through the exercise. These complex exercises. The idea is to go step by step, and but yeah, I see that for instance to remove the NAs could be a little bit tricky. So we'll see how can we do that. Okay, so the challenge is create a new data frame from the survey's data that meets the following criteria. Contains only a species ID column and a new column called hindfoot CM. Okay, so let's go step by step. Surveys. Get a pipe here. And now they said that create a new column that is, okay, so we need to use a mutate. The name of the new column is hindfoot CM. That will be equal hindfoot length divided by 10. If it's a millimeters and I want centimeter, yeah, divided by 10. Okay, well, okay, I forgot the pipe here, and I want select. I want only species ID and the new column hindfoot CM. What I will do for debugging, I will print the head. I will print the first 20, for instance. Okay, so I'm doing that. So this is part of the exercise. I get those two columns, species ID into the CN, and I want values that are less than 3 and no NAs. So you see that the first 20 are all wrong because I get either NA or values that are greater than 3. But what this is easy because so now that we have that, we can go step by step. So the first step will be to filter these values. So we can do filter. We can say that the input Fujian is all values are less than 3. Okay, so should be less than 3, 5. Okay, so if I execute that, you see that now species ID and Fujian has this. We get. Well, I will get rid of this. So I get the table now is 15. So I filter now all values are less than 3. But I imagine that if I print all of them, some of them will contain an A. The way, or only with this, let me, I'm not entirely sure. Because it seems that it filters. I can do the other way around. I can use a filter and say is.na in the footer CN type. Okay, it seems that when I do this filtering, I also filter the NAs. One way to let's get rid of this. So if in case that we are not sure, we would need to do two filters. The first one would be filter. So the way is not is .na input CM. So if I do that, I get this. So what I can do is now do another filter. So I can do in the foot CM less than 3. But it seems that the second filter also does the first one. What the solution of the exercise said is to use this. Using that, you do surveys, you do the filter, you get rid of the NAs, and then when you calculate this column mutate, you save, let's say, energy in terms of because you have done a filter, so it's not the same like create a new column of having 34,000 entries data column that you have less entries. So now you have this column, you do the filter and you select. Is that clear? This is that is a question that why I'm using an exclamation mark. This is to negate because if I have a vector that is true, false, if I use this symbol, each element is a negation. Negation means that if it's true, it's converted to false, and the other way around. And if I do the filter, is NA, it returns true if it's NA. But I want to, as you remember from yesterday, the conditional formatting is that if it's true, you return the element, and if it's false, you don't return the element. Because we want the elements that are not NA, we will need to do this negation. Is that clear now? Yeah, yeah. Cool. So yeah, this is the solution of the exercise. Yeah, exactly. So we can do it to see the, for instance, if here what I need is I need to specify surveys. And something is wrong here because I'm okay. That's I always thank you. Yeah, this is the I always made this mistake. I always write HT rather than TH. Thank you. So if I do that, returns false if it's NA and returns true the otherwise. Yeah, I see that I'm not the only one making this mistake with the typo. So this is because the condition if is as the let's see the function says is NA. So if I want to get the opposite, I will need to use this exclamation mark. You will see that it's a false, false, true, true. If I do that, I get the opposite. I get true, true. So that's why I'm using this. Cool. So let's continue with the. Okay, so this is regarding mutate, and we have another. The idea now is to group by a certain column and to get some statistics about that column. Okay, let's see two examples, and now we can continue with the first one is yeah. So the solution to this challenge is this here is this one. So I get the data set is 15,371 columns, sorry, rows, and 2 columns, species ID and heat foot centimeters. So here is I can try to copy and paste. I'm not sure if the format. Oh, okay, yeah, seems perfect. this will be the So what I want to explain now is well, I will take that you want to copy. I will group by this case is good when I use columns of categorical data, group by a certain condition and then summarize. What does mean is we have surveys, pipe, and I want to do group by sex, for instance. I want to get the mean weight by sex. So what I can do is I get another pipe and I do summarize. Also here you can use either let's say British English spelling that is with the S. Also you can use a Z. So whatever you prefer, I will use a S. And here summarize, you can create a new column that is a mean weight that is equal mean. We use the function mean weight. And then remember that you can get rid of the NAs with the na.rm equal true, because by default is false. So if I execute that, I get the following. I get sex, I get the female, the average weight is 42.2, and for male, the average weight is 43. If I want more, because this is like a quite let's see, simple, doesn't have that much information, I can group by sex and also by species ID. So I can add two, let's say I can group by two columns. If I execute that, I get that for each, for sex female, so I get for each species ID, I get the mean weight. And now I can do, with this, I can do some plotting and I can do some calculations. So this is the idea that we normally for this we use columns that contains categorical data that has factors. And we can do more. Here I'm using the mean weight, but also to summarize I can use more. I can use the minimum weight equal minimum weight and a.rm equal true, maximum, standard deviation, etc. So if I execute that, I get the average weight and the minimum weight. I see that I get some warnings. I'm not sure why. Yeah, I think it's complaining because they said that this is not. Okay, that is because I'm executing here at the beginning, this is not needed. Okay, so let's try. But yeah, I don't fully understand the warning, but well, it's just a warning. So and now it's not working because I forgot this. Okay, I'm doing something wrong. Okay, thank you. Is this? Yeah, I know that. Yeah, the 28 warnings. I can maybe see if I do a Python print. This is 86 more, so will be 10, so will be 92. Okay. The warnings are because yeah, the warnings are because of this. I'm using an A. We don't have any. Well, here I get a none. That is this is not a number, and I get infinite. So seems that okay, there is this combination exists, but this combination doesn't exist. That's why we get the warning. If I want, because I don't want to, I can do a filter here. I can say filter is dot NA sex, and again, sorry, taking this. Yeah, just a warning. So it seems that if there is a missing value, return if. That's fine. This is print because by default it only prints the first 10, and they said that here in the a hint that is a user print n to see more rows. But yes, you can do something like that. You can do filter, you can group by, and then in summarize, you can create the columns that you need to get the mean weight, minimum, maximum, standard deviation, and also another function that is arrange. You can sort a column by, for instance, a minimum weight. If you execute that, you see that now the minimum weight is sorted. Also, you can dex use from maximum to minimum, so you will need to use the function dex. I see that there is a question in the chat if I will share this script. Yeah, I can upload it. I'm following this lesson, but yeah, I mean, I'm happy to upload it. Just like most of the commands are copied and pasted from that lesson, but yeah. Okay, so what else? I think, let me see if we have a. Okay, there are two more things that we can do. This, we can calculate some statistics based on categorical data, and also we can count. We can say how many for this. Can do surveys. I can count by sex. And I can get sex, and I can get the number of entries. This is the pretty similar when we do a summary surveys $sex. Okay, it's not working because it's not. But this should be a factor in order to. So you see that this is this is the same data, but yeah, using different. Another way, if in case that I want to execute this again and I want to get the count, this is the same that I have executed before. I can also create a new column called count. Count. The function will be n. Let's get rid of this. So now you see for each sex and for each species ID, you get the average weight, the minimum, and the count. Using you need to use this function n. Okay, so I think what we will do now is we will have an exercise, and we have a break from 11 to 11:30, and after the break we will see how we can reshape the data frame, and we will export the data in order to do some visualization. But first of all, the challenge. So actually R3. So the first one is and the third one is this one. Oh, well, actually I will, no, well, this one. I will copy that in the chat. So these are like three exercises. So I will give you this, well, until 11 to do them. And also if you want to spend some time during the break. and after that we will continue. If you have any questions, please let me know. I'll be around. Okay, so it's 11:30. Welcome back. We will continue with solving the exercise that I mentioned before during the break, before the break, sorry. So the first part is how many animals were caught in each plot type survey. So, okay, so here I will need to group, okay, uh, so I will need, so it will be surveys, the pipe, how many, so I will need to group by a plot ID. Sorry, thanks. Yeah, I didn't share my screen because okay, now it should work. So I will start. So I would like to solve how many animals were caught in each plot type survey. So I will need the surveys, the type, this, and I will need to group by plot. Another pipe. I think I can use count. So if I execute that, I can see that for each plot ID, I get the number of animals that were caught. So this is the solution to the first exercise. The second one is using group by and summarize to find the mean, minimum, and maximum hindfoot length for each species using a species ID, and also the number of observations. Okay, so part 2 is surveys, pipe, group by species ID, pipe, and I think it's a summarize. I want the oh sorry, it's yeah, plot type. One moment here. Okay, so we have a plot ID and we have a plot type. So what that is just I just group rather number using plot ID. I use a plot type. Yeah, this is the solution. So depending of each yeah, for each plot type, I get the count. Thanks. Yeah, I didn't read the exercise correctly. Okay, so now I need mean and maximum. Let's continue with the second one. So mean in the foot will be equal mean the column that it will be in the foot length element of MA. Or if I want to get rid of this, I can filter this dot NA input. So the first step, well, get surveys. I filter the elements that are NA in input length. I group by species ID, and now I can calculate the mean, the minimum, input length, and the maximum. Let me check the exercise, minimum, maximum, and the number of observations. That is, I can use a number equal and is this the exercise? So yeah, this is the idea of, so for each species ID, I get the minimum, maximum, and the number of the count that I use the function n. So this is part 2. Well, part 3 of the challenge was, I will copy here. What was the heaviest animal measured in each year? Return columns, year, genus, species ID, and weight. Okay, so here let's go step by step. So these are the surveys. Select. So that we want year, genus, species ID, and weight. So we want this column. Also, I can do again, I can filter to make life easier. Start and a weight. So I want the heaviest animal measured in each year. Okay, so I will need to do a group by. So group by year. The pipe, there is this one, group by year. Also, I would like to get the summarize and get the maximum weight equal max weight. Because I think, let me. Because when I group by year, I get a year and max weight. Let me see. I think I don't need to use the summarize way. Oops. Okay, don't know what I click here. Yeah, this is a little bit tricky because the thing is that we don't need to do summarize, so we will need to do a group by year, and once that is a group, I will need to make a filter. Say that the weight is the maximum of the weight per year. And now I can select year, genus, species, and the weight. Sorry, that the thing is when rather than click Control Enter, I don't know why I use Control Shift Enter and execute the whole notebook rather than. That's why I'm getting all of this. And this is because sorry, I'm missing this. There's an error in filter. Because I'm doing an assignation rather than. So this is the. Also, we can. These are the. If we want, we can also sort by year. And if we want, we can print all. That to print all, we have a 27, so I equal 27. So now I get for each year, I get the genus and species and the maximum weight. So just to recap, I print surveys, then I filter the weights that are not an A. I group by year, and grouping by year, I can filter. I can get the maximum weight per year, and I can say that the weight should be equal to the maximum weight of each year. And now I can do select year, genus, species, and weight. I sort by year, and I print the whole. Is there any questions with this? If not, I will continue, and what I will do is I will share my because that is another way that we can do, but I think it's better if like show the sample that is in the documentation rather than to stop sharing. And share my Okay, so this is just to explain that also we can do it's called pivoting that we have. Imagine that you have this subset that you have a plot ID, 1, 2, 3, you have the genus, and you have the mean weight. And for could be for plotting or for your conference article paper, you want to use this column here. You want to use it as the names of the columns, and use this column as the values that contains. So you can go from a longer format, and you will get plot ID 1, 2, 3 here. But you see that there are three different genus. This one will be the three different names of the columns, and all of this data will go here. So the way to do that is using you also using pipes. So the data frame is a surveys GW, that is this one, and you use a pivot wider. So you get names from genus, so the column with the new variable names, and by values from, you get the column of the values for new variables. The other way around, you can have a table that is wide, and you want to use the column names as entries of a column called genus, and the values will be to this column as well. So you will need to do service GW pipe and use a pivot longer rather than pivot wide. Instead of names from, you use names to. So this is the new column that you generate, and values to is all of these values that have this table goes to this column. And also you specify the columns that you are reshaping. So you are pivoting using plot ID. So now plot ID will be duplicated, or duplicate will be the values will be repeated. This is to do the reshaping using pivot longer and pivot wide. And now the last part of this lesson is to clean the data and export the data. This data that we export, we will use it to do some plotting. So I will share again my screen with RStudio. And I will create a new that will be I will create a new data set that will be called surveys complete. So this is a surveys underscore complete. That will be, we will assign surveys type, and what they will do, they will do some filtering in order to get rid of the NAs that I have in weight, in input length, and in sex. So we do filter is NA weight, NA input length, So I will do this. And now if I print the survey is complete, you see that I now have a less. I have now 30, a little bit more than 30,000 observations. But the columns sex, input length, and weight doesn't contain missing values. This will be useful later for plotting. Also, imagine that I want to get rid of the rare species that have been observed less than 50 times. So here in this step, I got rid of the NAs. You can say remove A's. And I will do a filter species where the count is select. So the way to do that is I will create a temporary species count that will contain the survey is complete. We'll use a pipe, and I will count the species ID. I will do a count of the species ID. I will do another pipe, and I will filter using the count to be greater or equal to 50. So now if I print the species count, I get the species ID and also get the end, that this is the count, but I have a filter. If you don't do the filter, you get 24 species rather than 14. And now what I will do is I will, the species that are here in this species count, I will use this to filter this surveys complete. How can I do that? So I will do surveys underscore complete will be equal to a survey, or equal, like we will assign again surveys complete I, and I will filter. The way of filtering, I will say that the species ID should be in my temporary, well, temporary, like this auxiliary data set that I have created, $species ID. So if I execute that, and now I print the survey is complete, we see that the rare species, before we got a count of 30,676, and I have a 30,463. So the rare species have been removed from the. So now that I'm happy with my data set, I can save it. Before we have used red CSV underscore CSV, and now I will use bright underscore CSV. I will specify the survey, that data set that I want to save. Survey is complete, and I need to specify the file name. So file will be equal data. So this is the folder that we created yesterday to save the, let's say, clean data. And I will use a surveys underscore complete .csv. And now if I go to files, and I click on data, I will see that I have my new file here. See, in data row, I have the original one that is 3 megabytes. I want to keep it, but for the next lesson, I want to use this one that is cleaner, or at least this is the one that I want to use for the, because could be another study that, for instance, you want to study the rare species, so you can do the filtering the other way around. So it always depends on the study that you plan to do. So that's why it's always good to keep the original file. And now that we have a survey complete, we can start working with the what I will do is I will yeah, there is a way of cleaning objects from the workspace. Yeah, and if you want, we can create another R script that this one will be only for plotting. We can start from scratch. So because I clean my global environment, I don't have anything loaded, so I will need to again to load the library tidyverse. But it seems that it's already loaded because they didn't show any output. And what I will need to do is load the surveys complete, the score complete, and now I will read CSV, and I will specify the data surveys, the file that I have created before. If I do surveys complete, I will get this. For plotting, I will use here. There are several. Well, I think that yeah, the library that is used, the most important one is ggplot. We will use the version 2, but it's like yes, we say are pretty similar. That the thing is the name of the library that we will use is called ggplot2. And the idea of this library is like as we have done before, we will build up the or figure. We will create first well the layout, and then we will keep adding things to that figure. So the first step is we will use ggplot, and now I need to specify data. So data will be our dataset surveys complete. So this is the first step. I imagine that if I execute that, as you see here in a plot, that I get a gray square, but well, you see that is empty. So when you execute that, nothing happens yet. The second step is will be the stack. The stack is we have the data, so we will specify the mapping. So mapping, we will use the function as, because I will specify here the x-axis and the y-axis. I will make a scatter plot, so the x-axis will be weight, and the y-axis will be in the foot length. And if I execute that, You see now that my graph changed. I will make this maybe a little bit, should be okay. You see that my graph changed. You see that in the x-axis I have weight, and in the y-axis I have a input length. But you see that still this graph is empty because I didn't specify the what I want to print. If I want to print a point, I want to print a line, I want to print a bar. So in this case, I want to print a point. And what I said that because this is like a build by layers, now I will add a new layer. The new layer is added using a plus. I will use a new line here, and I will specify geom underscore point. Now, if I execute that, take some time to do the graph, but I get something like this. I get a weight, I get the input length, and I get this graph. And this is the, let's say, a basic. Now I can do many other things with the, or what I said that this is like a build step by step, is because if I want, I can save this into a variable. I can say surveys underscore plot, save this, and now I can do surveys plot plus geom point, sorry for the point, and I can print this. So some things that I can do, or some features that because I have used geom point, but without any. There are a lot of parameters that I can use. One of them, for instance, is the transparency of the point. So I can use alpha equal 0.1. The thing is also another note when we use plotting is that there are many choices. So my recommendation is first to have an idea in mind. Okay, I want to do a scatter plot of this, and then you may wonder, okay, I don't like that. How can I make how can I find the transparency? So either going to the documentation or searching on internet. On the internet, there are many examples of plot that you can do. Here we will see just a very small part of all the features that we have with this ggplot2 library. So one of them, I can say, okay, I want this transparency 0.1. So I execute it, and as you see that now I have the points, they have a transparency of 0.1. And maybe here you can detect better which areas they have this. Since that there's more weight, the input length is more concentrated here. When it's larger, yeah, so you can find some patterns with that. Also, if you want to change the color, you can say color equal blue. So I like that it resort the text in blue. So and now you can do this using a blue color. There is an exercise in, well, there is an example here that I didn't try, that is loading the library XP, and it's using surveys plot plus geom underscore hex. So this is also another way you can use what is using here. Yeah, use this geometric and according to the count, use like a more use this color pattern. Looks okay, but that's the thing, that we have several. Maybe for this data set it works or doesn't work, but the thing is you can do several tests with the R, and once that you are happy with the result, we will see how to save that into a file. Any questions so far? Okay, I see that there is a question that when you do the plotting, rather than plotting here, is I think it's something with could be something with RStudio, or because I think you can save it. Oh, I didn't know that feature, that with these arrows you can see the previous plots. And also if I want to export, okay, if I want to export, also I can use this feature, that we will see how to use this using the command line, but remove the current plot, clear, or so it, yeah, I think this is something with the configuration of RStudio. Later I can have a look and see why it's doing this rather than it's also, it also could happen, for instance, if you're using the mm, because we are using RStudio, but imagine that you are using the terminal and you're using R, maybe you get another window rather than, so yeah, joys of computers. Okay, so let's continue. Let's repeat this one here. It would be like a more interesting to rather than having the same color, have a different color depending on the species ID. So one way to do that is that you would need to a color rather than blue would be the species ID. But if I execute this, it will fail because let's see that this color doesn't exist. But you will need to use this function as. But with this function, you say that the color will be related to species ID. So when you execute that, okay, there is a missing. You get this graph here. So you get that for each species ID, you get a color. So, any questions? Shall we get? What did you prefer? Did you prefer to do an exercise on this, or we keep going with the lesson? Okay, let's do. Okay, we'll do an exercise, a small exercise, and then we can continue. We'll do the exercise that is in the chat. That is use what you just learned to create a scatter plot of a weight over a species ID with the plot types showing in different colors. What I will do is I will copy here. So you will need to do the same, but changing the, rather than using weight and input length, I will use now weight and species ID. And the colors will be plot types. Once that you don't do the exercise, let me know and we can continue. Okay, so let's solve the exercise. Just to answer the question in the chat, the recordings will be available. I guess at the beginning of next week. So the recordings will be available here in this page. So not an issue. Also, from next week, if you have any questions, feel free to contact me. Happy to chat about this. Okay, so let's just solve the exercise. The exercise is, let me copy this. So this use what you have learned to get a plot of a weight over a species ID. Can have a little species ID. The weight represented in Y. And they said that the color will be the plot ID. No, plot types. So plot. Who was, I don't remember the name. Was plot type. I will try. See. So yeah, it's something like that. The thing is, yeah, with this alpha seems I will try without the alpha. Yeah, it looks better. This is what the exercise said. Is now we have a species ID here in this, and we have a weight, and we have what we have for each. But the thing is, you may notice before we have used weight and we have used input length. So we have used, let's say that this type of columns are numbers. So we get like this distribution. When we use a species ID, is a categorical data. So we have different groups. That's why this scatter plot looks like that. And when I use this type of plot, maybe the scatter plot is not what we want. We can use the weight. I mean, the thing is that the good part here is yeah, that we can color regarding plot type. But mm, here another way that we will see, we will copy and paste rather than using geom point. I will use geom underscore box plot is the new one that. So you see that we are going by layers. The first one is to define the layout. This here, so we have this is ID weight, but this is empty. We have used a geom point. We are not convinced, so okay, we will try with the geom box plot. And what I get is this, I get that for each species ID, I get the weight, get the like the maximum, the minimum, and also get like this all of these statistics of. There is another one in the documentation that you can use is the violin one. But for instance, in this case, maybe it's not that doesn't work as good as the previous one. So let's go back and do box plot. And because, as I said, we can use different layers, we can also print uh, because here we see the statistics, but we don't have an idea of like how many occurrences we have or the distribution. So we can add a new layer that prints that. This is called geom kit. That well, here is in the documentation. It adds a small amount of random variation to the location of each point. It's a useful way of handling overplotting caused by discreteness in smaller data sets. So you can use that and see how it works. So we have something like that, but the problem here is that we don't see what is behind. So we can use an alpha over C 0.2, let's say, and color. I can use documentation, use tomato, but we can use any other, well, also colors then. Yeah, so it seems that Yeah, this is what looks like the. Also, for instance, here I'm plotting first the box plot and then I'm plotting the gitter. But what I not doing the, for instance, what I don't doing the other way around. I can do that. And if I do the other way around, okay, it looks like the box plot is on fire, but you can see better so maybe this one, yeah, I would say that this one is better than the previous one. Also, for this type, I might think that maybe a logarithmic scale could be better. So to use a logarithmic scale, I will need to use the function scale underscore y underscore logarithmic of. And so again, this is what I said, that we are like a building by, we print this, then we use this, then this, and then this. So if I execute that, well, there now you see this is like there is like a more space between weights. Yeah, maybe this might work, or maybe you find that it's not. Or for instance, if you don't like the result, okay, just do that and repeat again. So this is if we want to plot categorical data and we want to use the distribution of that data. What happens if I want to print time series? Time series, I can print over the years the count of animals by genus. So I have service complete. So what I can do is I can generate a new data set where I can filter that using a pipe, and I can say give me the count by year and by genus. So I get the year here, I get the genus, and I get the count of each. So I can save that in a variable saying this will be called yearly underscore counts. And I can use this variable too. I can use ggplot. Remember, you need to specify the data that you want to use. So it's the variable that I have just defined, yearly count. And now you need to define the layout with eyes. So X will be the year and Y will be the N, the count. I execute that, so I have here year, N, but I need to specify now what they want to print, or the geometrical figure that they want to use, and I want to use a line. So if I do that, I get this ugly, because yeah, for each year you get this, but because I'm using a line, it's like a kind of connecting. I don't know. I don't know if that exists. Like a geom. Yeah, I never tried this, so I'm not sure if. Okay, so I can get something like that, but yeah, it doesn't look like correct. Just n is 100. Yeah, we need to investigate more how this is. Let's come back to the. What I can do, because that maybe the problem here is that we are plotting all the genera together. So what we can do is that we can create groups. So again, a new feature is in the mapping. I use X is a year, Y is N, but I can use the group will be genus. So if I print that, I will get for each genus will be a line. So now it's like looks like a less ugly. The problem here is that I don't have any clue of this line what corresponds to. So rather than group, I can use a color. And I get more information for each color. Sorry, for each genus, I get a different line. So that's the idea. It's like going step by step, having a look at and you can do it like here we are plotting everything in the same graph, but also we can do faceting, it's called. We can generate a small graph per genus. The way of doing that is, okay, I will copy and paste just to make things. Deleting that. This is the original one that, but I can add another layer, and I can say facet underscore graph, and the say facet is a facet is equal bars genus. And now you see that for each genus, I have a different graph. So I can see the tendency of each one. And also if I want, I can use and print in each facet by sex. So I can use inside this here what I have used before, color equals sex. And it fails. Why it's failing? Object sex is not found. Ah, okay. Yeah, this is because in yearly counts, if you print that, we get year, genus, and so I will need to generate a new that includes. So I will need to generate yearly sex account, but this will be surveys type and the count. We made the count by year, genus, and also I want to count by sex. Ah no, because this survey is complete. The error that I get is that the object doesn't exist. If I print the yearly sex, Now I get the year, genus, sex, and the count. So now I can use this one to plot. So now I get for each year, sorry, for each genus, I get the count per year, and I get the, depending on the color, I get if it's a female or a male. Don't worry, all of this is in the documentation, but I will share the link in case that you want to have a look at that. Also, what I haven't explained is that we can use because here we use a year end, but we may want to give a title, or we may want to give I can add a new okay, we'll copy and paste this here. If I want, I can say I can specify the labels of I can say title equal sorry, genera to time. I can rename the x-axis, so I can say year of observation. Y could be number of individuals rather than n. So if I execute that, see that now I'm getting this. I'm getting this. Also, another thing that appears in the documentation that is a little bit like a more complex is you see that the years here appear like a one on top of the other, so are not readable. So in this case, you can go to, I will normally do is I will go to Google and search, well, you can also search in the documentation here, but I will go to Google and say, how can I change how can I rotate the text that appears in the x-axis? So one thing that you may do is thin and use axis dot text dot x equal element text. The thing of this is that this part of the lesson is to show all of this, or to show a small part of the features that this library has. You don't need to remember everything because it's impossible. But what you should learn, or is like if you want to do something, you will need to find how to do it. But let's see that in most of the cases it's possible. So here what I want to do is rotate, use an angle equal 90. And I want to see if that works. So you see that here, rather than using, I'm rotating the text that is in the x-axis. And I'm rotating that, but I can change also the font type, font size. I can use italic. I can do a lot of things with that. Also, I can create several plots and put them one on top of the other. There are like many ways to. Do you have any questions so far? If not, the last part of this lesson will be we will create a new folder here. I will call it EMG, and we will save the plots that actually I like it this one, so I will save it. So to save it, you can use my plot, and you save all of this output here. You save it in this variable. Execute it. And now what I can do is I can do gg save. I will need to specify the name. So this will be img, we will say genera.png. I will need to select the plot that I want to save, so will be my plot. And now I will need to specify the width of that will be 15, for instance, and the height, that will be 10. So if I do that, and now I go to Files, img, I will find this file here. So if I click on Open the file, you will see that this is open using this, and you see that the resolution is quite big. It's quite, and this is a nice plot that you can use in your now if you do a presentation in a conference, paper, and in with a few steps, we have done the. So there is a question here, interesting question actually, the differences between the like a pipe and plus. I would say that the concept is pretty similar in terms of for the previous library for when we were working with the data, we were using the pipe to process the data. So we have let's say the data set, and we want to do filter, select, mutate, etc. Here, what the idea of with the plotting, what we do is we go with the we think on layers. So first we plot the layout, the mapping, the X and Y, and then I adding I adding the figures, I adding some themes, it's like I'm building up this. So it's like I would say pretty similar, but it's like a kind of what they have in common, that you are going like a step by step, and you are like a building up either the the data that you want to get, or you are building up also the plot that you want to generate. Not sure if that answers your question. This is zoom to fit. Well, this is like the image of like a problem. So yeah, this is the. So yeah, actually it's quite big, and also we can play with we can select as well I will try and see, this is I will repeat this and see the difference. Let's say genera 300 dpi, because I can also specify the dpi. I know that some articles ask you to. If I execute this, well, actually this seems the same. Seems that by default. Okay, you see, if what I have done is I select this and I press F1. So since that by default the DPI is a 300. So what I have done here, okay, is just like maybe it's a way to ensure that this is 300, but by default you do this. For instance, yeah, you need to specify the width and height so that you can use scale, limit. So you have all of these, the background color, limit size. So you have all of these options. By default, it takes the device, it takes according to the file name, EPS, PS. So also, if you are using LaTeX, you can save the image in EPS, PS, text, in TeX, PDF, JPEG, TIFF, PNG, BMP. You have many options. So that's also what I recommend to, for instance, I don't know if labs have a, yeah, labs here. You have modify axis, legend, and plotter layer. So you have title, subtitle, caption, tag, or so you have all of these. Let me try before we finish this to see how it looks. I never tried this. My imagination is like running out a little bit. So I will save this again. If I open this, okay, this is what it does. Print the title and the subtitle here. Now, for instance, here the font is like pretty similar to this one, so maybe you want to like make it smaller or make it italic. All of this is possible. Okay, so this is what I wanted to show about plotting and about R. Tomorrow we will see some SQL, and also at the last part we will see how to combine R and SQL in case that we want to use the features of R, because with R you can connect to a database. Because here we are reading from our data set comes from a CSV file, but of data set also could come from a database table. So you can do basically the same, but the only thing that changes is the origin of the data. If there are no more questions, I think it's now time for a deserved lunch. Thanks for attending today, and see you tomorrow. Have a nice rest of the day. Again, if you have any questions, you can use the search pad. I will share the link here in the chat. If not, see you tomorrow. Bye for now.